Welcome to Cut and Paste. In this lesson I'm learning to solve multiplication problems using doubling and halving, thirding and trebling, and other proportional adjustments. Let's start with an easy question. I've got two groups, and in each of those groups I've got 10 counters, and I want to work out how many there are in total. Now over here you can see I've got my two groups, and there's 10 counters in each. Start by doubling and halving these numbers here. I'm going to choose to double the 2. So to double a number, I need to times it by 2. 2 times 2 is 4. Now, since I've doubled that number, I'm going to have to halve this one. And to halve a number, I divide by 2. 10 divided by 2 is 5. Now since we've made one side twice as big and the other side half as big, we should have exactly the same amount of counters, just organised in a slightly different way. Well, my new question says I need 4 groups, and in each of those groups there should be 5 counters. Let's see if I can do that on my picture over here. Well, if I put a circle around these first 5 counters, that's one group. If I put a circle around here, it's a second group. I could put these counters together for my third group, and I could put these ones together for my fourth group. So you can see I now have the 4 groups that I needed, and there's 5 counters in each one. So since I haven't had to add any counters in or cross any counters out, you know that 4 times 5 is the same as 2 times 10. So 4 times 5 is 20, so 2 times 10 must be 20. Now let's see if we can use this method to solve a harder question. Let's try 18 times 3. And we worked out before that we can make one side half as big and the other side twice as big. So in this example here, I'm going to make the 3 twice as big, so that will become 6, and I need to make the 18 half as big, so to do that I'm going to divide by 2. 18 divided by 2 is 9, so now instead of having 18 times 3, I've now got 9 times 6, and that's a much easier question for me to answer because that's on my tables. 9 times 6 is 54, so 18 times 3 is 54. You notice in this example how the answers are the same here. The only thing I'm doing is I'm just changing the way this question's set out. Instead of having 18 groups of 3, I'm just changing it so that now I've got 9 groups of 6. Let's try another one. Let's do 50 times 12. Now I need to think which of these numbers will make this question easier if I double them. Well, if I double 50, so I times that by 2, I'd get 100, and I'm really good at timesing other numbers by 100. Now since I've made this side twice as big, I'm going to have to make that one half as big, and I do that by dividing by 2. 12 divided by 2 is 6, so 100 times 6 is 600, so 50 times 12 must be 600. Now let's try an example that involves thirding and trebling. Let's try 3 groups of 21, and I want to work out how many counters that is in total. Well, over here you can see I've got my 3 groups, and in each of those groups there's 21 counters. So thirding and trebling is very similar to doubling and halving. Let's start with this one here. 3. When we were doubling, I had to times it by 2, but since I'm trebling, making something 3 times bigger, I need to times it by 3. 3 times 3 is 9. Now, since I made that side 3 times bigger, I'm going to have to make this side 3 times smaller. Another word for that is thirding it. And to do that, I'm going to have to divide by 3. 21 divided by 3 is 7. So when we doubled and halved, we times by 2 and then divided by 2, and when we third and treble, we times by 3 and divided by 3. Well, let's see if this actually works. Let's see if I can change this problem from 3 times 21 into 9 times 7 using our picture of counters over here. So I need 9 groups, and in each of those groups I need 7 counters. So what I can do is I can come down here, go around there, and I've got one group of 7. Now I'm going to go ahead and see if I can do all the rest, splitting them into groups of 7. So looking at this picture here, you can see that I have been able to change 3 times 21 into 9 groups of 7. Because over here I've got my 9 groups, and in each of those groups there are 7 counters. And I know the answer to 9 times 7 is 63, so the answer to 3 times 21 must be 63. And I know that's right because when I was splitting these into my 9 groups of 7, I didn't have to cross out any counters, and I didn't have to add any more counters in. So 9 times 7 uses the same amount of counters as 3 times 21, they're just set out a little bit differently. Let's try another question that uses thirding and trebling. This time I've got 2 groups of 24. So I'm going to try and change this using thirding and trebling. Well, I could make that side 3 times bigger, so I'd need to times that by 3. 3 times 2 is 6, and since I've made this side 3 times bigger, I'm going to have to make this side 3 times smaller, which I do by dividing by 3. 24 divided by 3 is 8. Now I know the answer to 6 times 8 is 48, so the answer to 2 times 24 must be 48. Now we don't have to just double and halve and third and treble. Let's have a look at this question here. 15 times 20, or 15 groups of 20 counters. And the first thing I think when I look at that question is, wouldn't it be easier if this 20 was a 100? So to change that 20 into a 100, I would have to make that side 5 times bigger. So if I've made this side 5 times bigger, what do you think I'm going to have to do to this side over here? A bit like when we doubled and halved and third and trebled, this side's going to have to get smaller, and I do that by dividing by 5. 15 divided by 5 is 3, and now I'm left with 3 times 100, which is 300, a much easier question for me to answer. So I know that the answer to 15 times 20 must be 300. Because 3 times 100 uses exactly the same amount of counters as 15 times 20, they're just set out in a different way. I hope you've found this lesson helpful. For more lessons, check out teachertools.co.nz.